Okay, so I've got some problems to work through today. I put up, I'll get the Zoom thing to go away. So, where is it? So I uploaded, instead of kind of using your grade from kind of the online quizzes and Connect homeworks, I put up what your grade would be with your lowest of each type drop. So here's your Connect grade with the lowest dropped. And maybe I'll update the names that says like with drops, just so it's a little bit more clear. I put your Excel grade with the lowest one dropped, your online quiz grade with the lowest 3 dropped, and then your individual assignment with the lowest dropped after kind of grading those last individual assignments. Okay, so these are going to be your grades in those 4 different homework type categories. And then obviously you have your highest and lowest exam grade, and then you can kind of play around with, well, if I get this grade in the final, would that figure out your grade tool, which you can find under files. All right, where is it? Here it is. Also, kind of going into the exam, you'll have kind of that final exam formula sheet. We're going to be going through this final exam practice file today. If you have any other, I posted that individual assignment number 3 answer key. It's not, specific to your assignment, but it's kind of just more general. Like if, it's a little bit different of a data set you can look at to get just another example of how you would answer those questions that I had in individual assignment 3. So that's some good study material there. With that being said, if there aren't specific questions on any of these kind of practice problems, I do want to work through these today. I think that'll be the most beneficial for some things that you could see on the exam, which I do have written. It's going to be about, I believe I have 13 multiple choice questions on there, and then 4 short answers that have kind of multiple components. So, the majority, kind of half of the points are going to come from the multiple choice, and or a little less than half, and a little more than half will come from the short answer. You'll have 2 hours to take the exam. It'll open up on Monday, as soon as it is Monday, and then kind of you have to get on and complete it. Once you start, you'll have 2 hours, and it has to be submitted by the end of the day, so 11:59 on Wednesday. Okay. All right, so I've got this final exam Excel file open as well. Let's see what we've got up here. So it's kind of working with that GPA data set, right? We'll answer a few questions. So I have kind of sheet 1 here and sheet 3. Sheet 1 has a few more variables, and you'll kind of see why as we work through this. So suppose we want to run the following regression where we just want to look at the relationship between GPA and total credit hours. Right? We believe that the relationship isn't linear, right? And that there's actually kind of some curvature to it. So we include a squared term as well. So what might we expect the signs of beta 1 and beta 2 to be? Right? Well, here, right, I'm thinking about, if I'm trying to draw out this relationship, as I take kind of the first few credit hours, right? If I have this is total credit hours in college. So if I'm looking at low numbers, that's looking at kind of like freshmen. And then if I'm looking at high numbers of credit hours, that's going to be, seniors. Right? So perhaps I think that, initially the GPA, right, as I increase the number of credit hours, or like kind of think about this as experience in college, initially taking a few more classes, maybe that's, through experience, I'm able to kind of perform better at this college level. And so maybe there's a positive relationship, right? As I take a higher number of total credit hours, maybe it matters less, right? So I'm thinking about initially there's going to be a really strong effect from taking additional credit hours, right? Getting more experience. But eventually, right, once I'm a junior, I kind of know how college works. That experience really isn't going to be as beneficial. It's not going to help me improve my GPA as much. So what I just described, right, would be something like, how would I draw that out? So if I'm thinking about, I've got GPA up here, and then kind of my credit hours are that on the x-axis. So I thought initially, as I take an additional credit hour, it's really beneficial, right? I'm getting that first college experience. As I take more and more additional credits, or more and more experience, kind of that experience starts to kind of dwindle. Like the additional boost I would see my GPA perhaps kind of dwindles, right? So I'm thinking I have an increasing relationship, but at a decreasing rate. So we're thinking about the signs of those coefficients. And actually, I think I was using betas there. So beta 0 plus beta 1 times total credit hours plus beta 2 times total credit hours squared. Whoops. Let's see if I can get a little better shot. There we go. So if I have a positive relationship, then on that linear term, I'm thinking this is going to be greater than 0. But if it's increasing at a decreasing rate, then I'm thinking the coefficient on my square term is going to be negative. So that would be kind of how you sign those coefficients. Now, if for some reason you explained a different relationship that you believed, I don't know, for some reason it was negative, right? Maybe I'm taking more classes, I have an opportunity to do worse. Then you would kind of draw out the signs, you would put a different sign to each one of those coefficients. But for the example we have, it's likely that, going into it, we're thinking this is likely positive and this coefficient on the square term is likely negative. So we go ahead and we run the regression, and sure enough, we find kind of this positive term on the total credit hours, and then the square term is negative. Now, even if I didn't give you the assumed value, like let's say I show you this output and then ask you to draw out what that relationship is, well, because you see a positive coefficient on the linear term and a negative coefficient on the squared term, it's going to be increasing at a decreasing rate, and that's how we could have kind of come up with that drawing. Right? Even if we didn't just base it off assumptions, we base it off the actual coefficients. Okay. So the next thing I want to make sure we go over, well, we'll go to 3 first and then come back to 2. So for 3, because I think it will take a little bit less time on 3. If I included all the variables I have as independent or control variables on the right-hand side, which are significant at the 99% level. So in question 3, I ran this regression in Excel, where I basically selected every single independent or X variable I had information on. Right? All I would do to determine which ones are significant is go through, right? And I type the word out here, but I actually could say, okay, what levels are they significant at? Right? Well, if I look at high school rank, that p-value is pretty much 0. Right? And so if the p-value is 0, we only reject if the p-value is less than alpha. So we could play around with different alpha values. Let's say I wanted to know, are these significant at the 10% level or an alpha of 0.1? We go look at high school rank, p-value of 0, definitely less than 0.1. So I say there's a significant relationship. I reject the null hypothesis, which the null hypothesis, is always that slope coefficient is 0. So if I'm rejecting that, I'm saying there is a significant relationship between this X variable and my Y variable. I then go down to the next variable of athlete, look at the p-value. 0.001 is less than 0.1, so yes, that's a significant relationship as well. What about for that verbal math test? I look at the p-value of 0.08, that's less than 0.1, so I can say, yeah, that is significant at the 90% level. But if I wanted to compare it to an alpha of 0.05, and I look at that 0.08, well, it's not less than 0.05, so I'd say that it's not significant at the 5% level. And it's not less than 0.01, so it wouldn't be significant at the 1% level. The way that I have kind of written these, I was kind of using it as assuming that we were comparing just to that 90% level, or that 90% confidence level, or the 10% significance level. But you could do that, you could make this decision for any alpha value. If we just do it for this 0.1, we go through, all we're doing is saying, look, I wrote these out assuming it was for an alpha of, 0.01, looks like, right? So high school rank, p-value is less than 0.01, significant relationship. Athlete, less than 0.01, significant relationship. Verbal math test, not less than 0.01, so there's no significant relationship. I can't reject this null hypothesis, which is that slope coefficient is 0, or there's no relationship between the score on this verbal math test and someone's GPA. Similar here, total credit hours, just barely not less than 0.01, so not significant, so on. You can kind of imagine so on and so forth, right? And kind of the one thing to remember here is when I say this e to the negative, remember we said those are basically p-values of 0, okay? Any questions on that? Stop. Oh, sorry, my cat is interrupting. So that's how we make kind of rejection decisions and determine if things are significant at different levels, right? And the significant levels we're typically thinking about are kind of the 10% level, 5% level, 1% level, which gives me alphas of 0.1, 0.05, and 0.01 to compare to, okay? Any questions on that before we kind of keep moving here? Okay, and you'll always be given the p-value in the output, right, in the Excel output, if I ask you a question on it, about it on the exam. All right, so now let's go to question 2. So this is something we haven't talked, the last 2 things we're gonna talk about, we haven't really worked through examples this week on, and so I wanted to make sure we reviewed them again. So suppose I want to use dummy variables that identify kind of the different race gender combinations of these individuals. So I create an indicator variable that's a 1 if the individual was a white male, 0 if not. Another variable, it's a 1 if they were a white female, 0 if not. Non-white male, non-white female. I do the same thing there. So these variables show up on this sheet 1, right? These indicator or these dummy variables right here. Right? Now, if I wanted to kind of determine whether or not there's potentially some discrimination going on or with race or gender based off these variables, which of these would I include, right? So tell me which ones you would include, and then how would I interpret the coefficients? Right? Well, in question 2, oops, sorry, I decided, well, if I have, these 4 different variables, right, the individual has to belong to one of these because I didn't, kind of specify a race here. It's just non-white, right? Or we can think about it as kind of minority male and then minority female. Well, the problem is if I include all these variables in my regression, I'll kind of show you the problem. So go down here to regression, hit OK. I want to try to predict GPA. And then I'm going to include all of them, as well as just the SAT score variable, so I kind of have some measure of the individual's intellectual ability, right? I selected my labels, I'll put this on another sheet. Now I look at this output. Well, how am I getting? I'm getting some errors here, I'm getting zeros. Well, that's because when we had these dummy variables that represented categories, we said we had to leave one category out so that we had like a reference group, right? So my idea was that looking at this data, if I want to determine whether or not there's kind of, I don't know, I would call it discrimination, but there's some something related to the race and the gender of an individual that is leading to kind of differences in GPA, I'm going to compare that to kind of this white male reference group and then only include these other 3 groups. So now the interpretation of my coefficients, if I think about what my regression equation looks like, it's GPA, got an intercept, so we'll call it B1 times, can't remember the order, but it doesn't really matter. So white female plus B2 times non-white male plus B3 times non-white female. And I think I also included their SAT score. So now the interpretation on these race gender combination variables, for example, beta or B1 here would be if the individual was a white female relative to the group we left out, so relative to a white male, the expected difference in GPA would be whatever this B1 value is. And then for B2 here, if the individual was a non-white male relative to a white male, B2 is the predicted kind of difference in that individual's GPA relative to that group we left out or relative to the white male group. So I look at this output. We're going to zoom in here so it makes it a little bit easier to see. Oops. So I can kind of interpret these coefficients and say, well, okay, a white female relative to a white male, we would predict their GPA, like holding everything else constant, which here is really kind of just SAT and these other 2. So if they're a white female relative to a white male, we would predict their GPA is 0.24 points higher. If they're a non-white male relative to a white male, we would predict their GPA is about, what, 0.009 lower. And then a non-white female relative to a white male, about 0.02 higher. Okay? So that's how we interpret, right? When we have like a set of dummy variables where I would have to belong to one of those categories, and I leave one out. For example, we did if we go back, we did the example with like college football conferences, right? You have to belong to one of them. And so we had to leave one out as our reference group. Or you could think about this as maybe we want to estimate the effect of, I don't know, car color on its price. Well, I would have to leave, I would include an indicator for if the car was red or not, if it was green or not, and then maybe, and et cetera, and maybe I leave out if the car was black, right? So that black car is my reference group. So every other coefficient would tell me relative to a black car, if the car was this color, I would predict the price would be whatever that coefficient, whatever beta was, that much higher or lower. Okay. Any questions on that? Or if I maybe any other examples? I don't know if you want to, any questions? Okay. So know that if you have something where you want to include a set of dummy variables such that every observation has to belong to one of those groups, you need to leave one of those groups out as your reference group so that you can interpret the coefficients as relative to that reference group. Here's the predicted difference in the y variable. Increase or decrease depending on if the coefficient is positive or negative. Now, one thing that's interesting here is, if we're thinking about race and kind of gender differences, well, the good news is if we're looking at kind of the difference between non-white males and non-white females relative to a white male, once we control for the SAT score, the p-values are enormous here, right? So there's really nothing kind of tied to race here potentially, right? We can't reject the null hypothesis at all. The one thing that's interesting is that the white female category relative to white male is highly significant, right? We're missing a lot of other control variables here, so it's not worth kind of thinking too hard about this. But it might be evidence that there's something kind of going on with gender here, or specifically the white kind of female group relative to even white male, non-white female. There's something that's kind of driving their GPAs up a bit, and so this is, I don't know, it's interesting, but so that's kind of what I wanted to kind of work through on this question, just kind of making sure that we know how to work with these multiple dummy variable examples. I then added in, I think yesterday, if you downloaded the file, I updated it after class because I wanted to cover one more type of example that you could see on the exam. And when I say you could see it, I have it written, so it's probably a good idea to know how to do these. So we talked a while back about kind of interaction terms. So let's say that potentially I think that SAT scores are good predictors of GPA, right? But I think that maybe they might not be as good of predictors, or maybe they're better predictors if the student is an athlete. Right? So I'm going to include the athlete variable, the SAT score variable, and then the interaction term of the two. So it's going to look something like this, right? I'll include this additional interaction term where I multiply the SAT score times that athlete variable. So now the interpretation here, we can think about it as for B1, don't capitalize it. Well, it's going to capitalize it, but there we go. So for B1, it's a 1-point increase on the SAT, predicts the student's GPA will be B1 higher, whatever that value ends up being. The interpretation on B2 is, well, 1 unit increase in the athlete variable is just a 0 if they're a student athlete, 1 if they're not. So student athlete relative to a non-student athlete would have a predicted GPA that is beta 2, and then higher or lower kind of depending on the sign of B2 or beta 2. We then have that interaction term. So what's the interpretation on this interaction term? Well, the interaction term is the additional effect of the SAT score if the student is an athlete. So the additional effect of a 1-point increase in SAT, or sorry, I guess I should say, on the SAT for a student athlete, right? So we could start to think about, okay, these are kind of our general interpretations when we include this interaction term. Let's look at the actual results. So I included on sheet 3 this additional column, which was just SAT times the athlete variable. So then I run a regression using these 3 control or independent or X or right-hand side variables, and I get this output, right? So if I look a little, zoom in on this so we can see it easier. So my SAT score variable is pretty similar to what it was before. For every additional point I get on the SAT score, it predicts GPA will be about 0.002 or 19 higher. My interpretation on this athlete variable is if the student is an athlete relative to a non-athlete, if they go from being a non-athlete to an athlete, their predicted GPA would go up by about 0.06. Now, if I think about the interaction term, what this is telling me is because it's negative, it's saying that the SAT score for a student athlete is going to kind of be less of a predictor for GPA. Because if I think about, well, what's the total effect of a 1-point increase for an athlete? Well, the total effect of a 1-point increase on the SAT score for an athlete would be, well, if SAT goes up by 1, it would go up by this coefficient. But also, if they're an athlete, this is going to be a 1, so a 1 times that 1 unit increase here as well. So the effect for an athlete is going to be, sorry, for the effect for a 1-point increase on the SAT score for an athlete will be the coefficient on the SAT score plus, and here, because it's negative, we're actually going to subtract it, plus the additional coefficient on the interaction term, right? So let Excel do that for us. So this is the effect of a 1-point increase on the SAT for a student athlete. And then if we think about here, the coefficient that's on the SAT score, well, for a non-athlete, the athlete variable will be 0, so this interaction term, 0 times anything is 0. The effect of a 1-point increase on the SAT for a non-athlete would just be whatever the coefficient was on that SAT score variable. Okay? So by including this interaction term, I can determine if there's a different relationship between the SAT score and the GPA for athletes relative to non-athletes. And it looks like here, here we do find a difference. Now, the interesting thing is, if we look at the p-value, well, the p-value on the interaction term is very high. So we actually can't say, or we can't reject the null, or we can't say that this relationship, this coefficient, the true value of it is really anything other than 0, because we failed to reject the null. But we could do this for, what was the other? I think I did it for female, it didn't work. Let's see. Let's try doing it with this race variable just so we get another example here. Okay. So I'm going to insert this here. So we've got this race of whether or not the individual is white or non-white. Oh, that's not what I wanted to do. I wanted to move this around here. My bad. Sorry. Give me 1 second. And now I'll include an SAT times kind of that race identifier. So just multiply those 2 variables, copy that down. I have no idea what these results are going to be, so we'll go to regression. Y variable is still GPA, so we'll select that. But now my X variables, I want to include the SAT score, the race identifier, and then the interaction term. So I select those 3, hit OK. Now here, if I look at these results, we'll zoom in so we can see them a little bit better. Now the interpretation, it's still a 1 unit increase in the SAT score, right? Has about, predicts that GPA will be about 0.032 higher. kind of that white variable predicts kind of a higher GPA, right? And this is likely related to, things that potentially the, resources they had available to them in high school, et cetera, et cetera. But the p-value notice here is pretty high, so we actually can't kind of say that the race of the individual has any impact on GPA at any significant level, right? But if we look at the kind of the interaction term, what this is saying is that for kind of white individuals, this SAT score is maybe less predictive, right, than for non-white. However, it also has a high p-value, so really we can't say that it's anything other than 0. But we could do the same thing here, right? We could say simply that 0.002, that's going to be the effect, or the a 1 point increase on the SAT for a non-white individual predicts GPA is 0.002 higher, right? That's kind of what we're thinking about there. However, a 1 point increase on the SAT for a white individual predicts GPA to be, we're not sure yet, higher, because the total effect if the individual is white is not only this 1 point increase on the SAT score here, but because the white variable we won, it also would cause a 1 point increase or this coefficient effect as well. So we would have to add those two coefficients, and we kind of see that for white individuals, that SAT scores may be less predictive. Now, once again, let's not make too many wild statements about kind of race here. We haven't control for a lot of other things. Also, really those differences in race, we can't really say they exist at any significant level, right? So really, even though we can make that interpretation, right, the actual differences in someone's GPA, we can't say that isn't related to kind of race at all. So kind of it's kind of an interesting example. Are there any questions on any of this that we've kind of worked through? No questions on that? How do we interpret just the white? Okay, so because it's a 1-0 variable, we're just thinking about that white coefficient, right? A 1 unit increase would be going from a 0 to a 1. So if the individual, instead of being non-white, was white, we would predict their GPA is 0.29 points higher. But once again, that's the interpretation. But if we say, well, is that statistically significant? Well, that p-value is 0.18, so no. We fail to reject the null, which is actually that coefficient is equal to 0. So really, at any statistic, like any significance level, we actually can't say that there's any impact of race on kind of predicting GPAs. Okay. Any other questions on kind of any of this? Like I said, I want to make sure we went through an example where we looked at interaction terms. Also made sure we went through one that had these kind of including several different dummy variables, but leaving out one to make sure we have a reference group. Is there any other questions? Because that's all the kind of review material that I have, unless someone has a question on a problem that we've already worked through, or something on one of the assignments. Okay. All right. Are there any questions on about the exam? It's going to be very similar to the other two, with the exception that there's quite a bit more of it's going to be from the short answer questions. You can use Word, Excel, scan something, take a picture of it and upload. But however you do it, you need to show me as much of your work as possible, because in order to give as much partial credit as possible, I need to be able to see that, right? If you give me a wrong answer and you don't give me kind of your work, it's harder for me to give as much partial credit. Any questions on that? Okay, could you go over more level, log, and log level and how to interpret the coefficients? I can't. So let me think of one I could do here using this data set. Let's do high school size. No, we'll just use the SAT. So let me do natural log of the SAT score variable. Actually, we'll do high school rank. And then natural log of GPA. So natural log of high school rank, natural log of GPA. So let's say that I do a log level model. So remember, the very first word, log, is going to be our y variable, level is the x. So I'm going to run this regression, and I'll type out what that regression would look like here in just a second. So my y variable, I'm going to be using the log of GPA. And my x variable, I'm just going to be using their high school rank, right? So log level. My independent, my right-hand side, my x variable is level. My y variable is a log, so hit OK. Oh, why doesn't it like that? Probably because there's zeros in there for high school. Let's see. I'm doing this on the fly, so forgive me. Are there zeros in there? There sure are. How the hell do you get a 0 GPA? Oh, there's 2 people. Maybe they enrolled and dropped out. Oops. What did I do? I copied. I want to delete them. Okay. Can't imagine there's a 0 in rank. Okay. I was going to say, that would make no sense. Data analysis, regression. We got rid of 2, so now it should just be to 1, 5. Hit OK. All right. So we've got our output here. So really, if we want to think about what we just did there, we took the natural log of GPA, and we said, here's the intercept, and our x variable is high school rank. Okay. So that high school rank coefficient is B1. Right? So if we're thinking about the effect here, you start out these interpretations. Usually it's a 1 unit change, but when we start to use natural logs, it could be a 1% change. But the change in the x variable is always whatever that x variable is. So here the x variable is just, we didn't touch it. So the interpretation is still a 1 unit increase in high school rank. Right? It's going to predict that GPA would be, now here, we think about if we have kind of this log level, we're going from units to kind of percentages. The effect, let me make sure I mix this one up. So if we, well, actually, I want to do something here real quick to kind of prove this point. I think this will help. So before we do that, let's run the other regression model as well. I think that'll be helpful to see the difference between the two. So let's go to data analysis, regression. Now I'm going to do a level log. So I'm going to do GPA, right? Level, the first word is the y variable. Log of my x variable, so the log of high school rank. Selected my labels, hit OK. Now I've got this, so I'm going to zoom in. And I'm going to label these so we know what we're looking at. So this was the level log. Was it sheet 5? Yeah, sheet 5. This is where we did the log level. So there's kind of one difference, right, in between these two types of regressions. One of them, we have to multiply by 100. One of them, we have to divide by 100. So if we look at this log level, if we're going from a log level, a 1 unit increase in our x variable, we'll predict that GPA would be whatever that coefficient is, so negative 0.00339 times 100 lower here. I mean, so we predict the GPA would be whatever this value is lower, right? Because we have a negative sign here. So if we move the decimal point 2 places, we're really thinking about it'd be 0.339 lower, right? So the log level model, you multiply by 100. And then for the level log model, Well, now our x variable is we're taking the natural log of it. So now instead of a 1 unit increase, it's a 1% increase in high school rank. Would predict GPA is negative 0.19 divided by 100. Or what, 0.0019, sorry, and actually this will be, once we actually do that, we would then multiply it by, sorry, not multiply it by, just put a, say it as a percent. So it's going to be 0.0019% lower, right, since we have a negative sign there. So level log, right, we're going to divide by 100. Log level, we're going to multiply by 100. Okay. Any other questions on that one? And we saw this on that individual assignment 3, the answer key I put up. Oh, here, where is it? So kind of a reminder, if we're looking at the log level model, right, that was where we multiplied by 100. If we're looking at the level log model, that was where we divided by 100. Okay. Does the intercept, so the only thing we're doing with the intercept here, and I'm not going to ask you to interpret an intercept for log models, but in a more general model, so let's say we go back to this one, the only thing we ever have to do with the intercept is say the interpretation is that if every other variable was equal to kind of 0 in this regression, the intercept is the predicted value of our y variable. So here, if every other variable was 0, this is actually a unique one. Well, they would, so we have 0 for white female, non-white male, non-white. So basically the individual would have to be whatever group we left out. So if the individual was a white male with an SAT score of 0, their predicted GPA would be 0.47, right? Does that make sense? And that's just always how we interpret the intercept. Sometimes it's going to be a really goofy interpretation. I mean, who gets a 0 on the SAT score, right? Or if we looked at when we included all the regressions, or sorry, all the independent variables, that regression, I mean, no one's going to have a high school that has 0 people in it. But that's still, you know, that's still how we, interpret that, right? And it's, you know, the idea is like, so why is it like, it's pretty goofy, right? Like, it doesn't really make a lot of sense. But if we're just thinking about there's a relationship, and it could be between any 2 variables, it doesn't matter. If we're thinking about, is it 0? Well, it could be that the intercept is negative. Let's say even if we were trying to predict SAT scores, or sorry, GPA from SAT scores. So we would say if they have a 0 on the SAT score, the predicted GPA is negative. You can't have a negative GPA. Well, that's because you also don't see 0 SAT scores if someone actually sat down and took it, right? I mean, it might be, you know, maybe there could be, I guess, but very unlikely, right? Most of our data is going to be somewhere up here. But in order to get that line of best fit for that data, we had to start out with a negative intercept. It's just that once we have more variables, the interpretation can be really weird because we're thinking about this like 8-dimensional space where we have like this starting point, and then if we could somehow envision 8 dimensions, as we move in all those different dimensions, it starts to move away from that starting value. Okay. Any other questions? No? Okay. So the other things I wanted to make sure I said, so I kind of went over some of the details of the final. I will be available Monday at 1. I'll create a Zoom link after class. If you have any last minute questions, I suppose a lot of you probably aren't going to take the exam prior to Monday at 1, probably want to as much time as possible, but I'll be available during that time to kind of answer any questions over any problem on the practice exams, any questions you have just in general. So I'll kind of be logged on to Zoom there. And if you want to kind of stop in and ask questions, I'll be here. Okay. Oh, I also wanted to remind you, I think I did yesterday as well, but just one last reminder. Hopefully it's the last reminder I get via email because I got one today. But if you can get on and fill out those student evaluations, that helps out. Also, I just kind of, I don't know how many of you will be here on Monday, but also just kind of this will be the last video I'm posting. But it was a good semester. I really enjoyed, I really enjoyed the time when we're in person. I wish this could have been a more regular kind of semester, where it was it could be a little more interactive. But I know that there's a few technical difficulties early on, so thank you for kind of hanging in there with me. This is the first time I've really taught a class anything like this, in terms of kind of doing this kind of two groups off and on. And so I enjoyed a lot of the questions that you guys had, and I actually really liked a lot of your individual assignments too. Some of the results from the data sets were really interesting, so that was cool to see. But thanks for a good semester. Good luck on the exam. If you have any questions, feel free to reach out. I've done a couple of Zoom meetings with students already today. Probably won't be available this weekend, but early next week, for sure, I'll be very available. Okay. All right. I guess it'll be the last video. I guess I'll see some of you on Monday. But if I don't, have a good break, and hopefully I can hear from you guys or see you around the building a little bit next semester.